Okay, so this is lesson 4.3 on how derivatives affect the shape of a graph. So we're going to be looking at the first derivative and the second derivative here. I'm actually going to split this lesson into two parts in terms of videos. So this is going to be part one on how the first derivative affects the shape of the graph, and then I'll do a second video for the second derivative. Okay, so let's have a look at these pictures here of these graphs of these functions. We have four different scenarios that I want to take you through. I'm going to use a yellow highlighter to talk about positive slopes or positive derivatives, and then a blue highlighter to talk about negative slopes. Okay, so let's look at the first scenario here. We see that we have a local maximum at x equals c, but let's look at the derivatives on either side of that maximum. Okay, so leading up on the left side of that maximum, we see that the graph is increasing. There is a positive slope there in that region. And then on the other side, there's a negative slope. Okay, so as the graph changes from having a positive slope to a negative slope, as we look at it from left to right, as you would read it, that means that the graph must have, right, it must be going up and then going down. That means it must have a local maximum at that point. So even if we couldn't see the graph, but we knew that it changed from having a positive slope to a negative slope, then we know that there is a local maximum at x equals c. Okay. The opposite happens when you switch this around. So if you have a negative slope on the left side and then a positive slope on the right side, that means that you are going to have a local minimum. So even if you didn't have this picture in front of you, but you knew that C was a critical point, and you saw that the slope was negative leading into the, or on the left side, and then positive on the right side, you know you would have a local minimum at your critical point, okay, or critical number. And it could also be the fact that your critical number is not a maximum or minimum at all, right? So here are two examples where you could find that. Okay, so let's say you have a critical number at C, and you look at the derivatives, and you just see that the graph is increasing, and then it continues to increase, right? So there's no local maximum or minimum then at C. And then same for if you have a negative derivative, and then it continues to be negative. And then you have neither a max or minimum. Okay, so we're not going to have these pictures in front of us, and instead we're going to make like a table and do some testing to figure out what's going on with the derivatives to decide whether we have a local minimum, a maximum, or neither. Okay, so let's practice doing this with an example. We have a polynomial here. Okay, so we're going to do the first derivative test. The first thing we do when we want to test is find our critical numbers, right? So we want to take the derivative here and find out where it's 0. This is a polynomial, so there's not going to be any endpoints or places where the derivative is undefined. We're just looking for where the derivative is 0. So let's take the derivative. Just using the power rule, it's going to be x cubed minus 3x squared. Okay, to find the critical numbers at C, okay, we're going to set this to 0. And we can factor to do this. So we see that there are two critical numbers, C equals 0 and C equals 3. So we're going to investigate these a little bit further by making a table and doing some tests. I'm just going to create a little bit more space for myself. There we go. Okay, so what you want to do in your table, you can kind of make like a number line if you want to. Okay, so we're going to test, I'm going to put on my number line, I'm going to put x equals 0, x equals 3. Okay, I'm going to test in, we know that, and then I'm going to test my derivative before, in between, and then after, okay, in all of these segments. Okay. All right, So let's check out the derivative before x equals 0. Now I'm going to plug in any value into the derivative that's less than 0 and see whether the derivative is positive or negative. I already have an expression for the derivative there, so I can test something like simple, like maybe I can test, I don't know, -1. Because the only places that the derivative is 0 are 0 and 3, that means that, I can test any value here and I'll get the same sign no matter which value I test. Okay, so if I test -1, plug it into the derivative, I see that I get a negative number, and so I'm just going to put a negative sign here. Okay, now I'm going to test the derivative at maybe a nice number in between 0 and 3, maybe like +1. Okay, so I plug that into the derivative expression. Usually I like to use the factored form because it's a little bit quicker. And I still see that I get a negative number. And then I'm going to pick something greater than 3. Maybe I pick 4. Okay, I'm going to plug it into the expression for the derivative. So 4 squared times 4 minus 3. And I see that I get a positive number. Okay, so what does that mean about the actual function itself? Okay, so let's make some conclusions here. Okay, the derivative being negative means that the function is decreasing. It's going downwards in this first region for all the x values that are less than 0. Okay, then in the next little section here, the next interval, the derivative is also negative again, so that means my function is going to continue to go downwards again in that section. All right. And then in this last section here where I tested a number that's larger than 3, I saw that the derivative was positive. And so that means that my graph is going to be increasing in this region, and it's going to have that kind of shape to it. Okay, so if I was actually going to sketch the graph, you don't have to do this, but it would look something like this, where it'd flatten out for a second, continue to go down, and then go up. Okay, so downwards, downwards, and then upwards, right? And we see we have a minimum at x equals 3. So that's my conclusion here. I would have a local min at x equals 3. There is no minimum or maximum at x equals 0. Because it continues to decrease on either side of that critical number. Okay. All right. So in conclusion, right, the first derivative test is super useful because given some critical numbers, you can do this test and test your derivative on either side of the critical numbers, and you can figure out whether you have a maximum or minimum or not. All right, that's the end of this first video. We're going to come back with the second video to explain the second derivative test and what the second derivative tells us about the shape of a graph.